Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Naim bin Hamizat. Today I want to present final year project. My title is an assessment of moisture induced damage in asphalt pavement with Nano Zinc oxide. In general, the asphalt binder is a co-product of the oil refining system that produces gasoline, diesel, lubricating oil and several other petroleum products, and moisture damage is asphalt moisture is related to the loss of durability and cohesion owing to water presence. Nano zinc oxide improve the water resistivity in asphalt pavement. My objective in final year project, firstly, to determine the potential of adhesion and cohesion of nano zinc oxide as a modifier in asphalt mixture. Second, to determine the effect of modified asphalt mixture with nano zinc oxide on moisture damage. The statement of problem is the major problem of asphalt mixture because of moisture damage in presence of water. Secondly, it could be described as loss of strength, durability, and stiffness leading to the presence of water, leading to adhesive failure in the binder and aggregate interface, and cohesive failure in the binder. For Chapter 2, literature review focus on general knowledge about asphalt binder. Secondly, about asphalt binder and additive. Secondly, nano material, and thirdly, focus on zinc oxide. For the conclusion in chapter 2 is the additive of nano zinc oxide give the achievement to increase the penetration and softening point of the asphalt binder. Secondly, based on Lopez, the tensile strength of the mixture increased for virgin sample fresh by modifying the binder with nanoparticle, especially when the binder is modified with nanoclay. When the mixture are damaged by moisture, their indirect tensile strength tends to decline significantly. So we use the nano zinc oxide because the literature review give the potential about nano zinc oxide. For chapter 3, we start the research with material preparation with nano zinc oxide, aggregate and asphalt binder. Then we mix the asphalt binder with nano zinc oxide. Then we make the mixture with aggregate. Then we create or build the asphalt mixture. Then we test in moisture damage test. Divide by 2 is water absorption test and indirect tensile strength. So we got the result analysis, then we proceed the conclusion. For preparation of material, the aggregate have to sit in the size range specified for asphalt concrete SC14 following for grading limits. Then the scope of design optimal quality of the asphalt binder used through 4% until 6%, and aggregate has batch processing the mixture in around 1.2 kg. The 60 or 70 grade of asphalt binder penetration used in this research. Then follow the percentage of nano zinc oxide. We use 0, 3, 5 and 7%. We mixture the temperature with 135 until 155 degrees Celsius. In addition, the blending process uses 2000 rpm to achieve a homogeneous specimen that to carry out in 30 minutes. We use research with testing standard. First, testing safe analysis, we use ASTM-D422. Specific gravity test, we use ASTM-C127 and C128. For indirect tensile strength, we use ASTM-D6931. In chapter 4, result and data analysis, the water absorption test show in this graph. In the case of specific aggregate type, the fine aggregate show higher specific gravities than coarse aggregate because the size aggregate particle is smaller than the coarse aggregate. The portion of the pore exposed to the aggregate surface larger. The data in figure show the volume absorbed water against percentage of nano zinc oxide used in asphalt binder show no consistency. However, it shows all the specimens have good in range of absorption water because it below 2%. In other research show the presence of nano zinc oxide induced an improvement in the surface roughness of the reinforced coating and often produce an improvement in the contact angle of the water as well as a decrease the free surface energy. For indirect tensile strength, the dry specimen show the 7% among nano zinc oxide asphalt anti-stripping agent is the most efficient, resulting in a surprisingly higher improvement compared to other percentage of nano zinc oxide additive used in weight of asphalt binder. For wet specimen, as the result demonstrate 7% of nano zinc oxide show the higher value of ITS indirect tensile strength others than the mixture of percentage nano zinc oxide that clarify the better cohesion of hot mix asphalt modified binder and also better adhesion of the binder to the aggregate than other mixture. It is because the potential factor is that the chemical structure of this additive contains majorly of the hydrophobic group. For indirect tensile strength ratio versus percentage of nano zinc oxide, as the graph show, the highest ITSR is 7% of mixture of nano zinc oxide, where the values highest is 82.48%. As the scale of nano zinc oxide particle reduces, the surface roughness of the asphalt will be increased. Then the joint force and adhesion between asphalt and the aggregate will be greater, and thus the water resistance of nano zinc oxide make the low temperature cracking tolerance of the asphalt mixture may be enhanced. For the conclusion, in water absorption test, when the increasing percentage of nano zinc oxide is cannot influence to affect to decrease volume of absorption water in percentage. The data show the asphalt concrete also factor the increasing of water absorption because in other research state the granite have high absorption water The percentage of nano-zinc oxide show no consistency about absorption test. However, all the mixture in good condition in water absorption test. Second, in the laboratory performance test of asphalt mixture, when the percentage of nano-zinc oxide is increased, moisture damage of asphalt mixture will improve ITSR from 62% to 82%. In summary, when the nano-zinc oxide percentage was 7%, the laboratory performance of asphalt mixture are the best. Third, according to the analysis above, the percentage of 7% of nano-zinc oxide is recommended for nano-zinc oxide particle. For recommendation, increase research of the crystallinity of zinc oxide in order to know about the quantity of zinc composite of powder, asphalt render and asphalt mixture. Secondly, increase research using sand and physan of asphalt render and mixture modified with nano-zinc oxide to know about changes nanostructure in every percentage of nano-zinc oxide. Thirdly, increase research using surface free energy method to find about water resistivity of nano-zinc oxide. Thank you to my examination panel, TS Rosnawati binti Bahari and Prof. Madya TS Dr. Muhammad Isri bin Abdullah for listening my presentation for final year project. Thank you.